What up, Suspendees? It's Ben from Suspendee Studios. So, I just want to go over the basics of GameMaker Studio 2. This is not every single little thing. This might take a while. This might not take a while. This is supposed to be a refresher. This isn't a replacement for learning GameMaker Studio 2, but I just want to go over some of the most important things in this engine that I'm going to try to utilize. And hopefully you'll understand, once I've shown them to you. Now, first off, if you open up a project, which I'm not going to tell you how to open up a project, just simple. Open up GameMaker Studio 2 and click New Project. But I start up a new project over here, Introduction to RPG. And we don't have this sprite over here, but if you want to go ahead and you want to create any of these things, if you want to create an object room or import something, you want to right-click it, and you can either do Alt-S, Alt-O, Alt-R. You do, for example, Alt-S, and there you go. And you can also just right-click the background over here, hover over Resources, and do this. Now, you can move around by holding down middle-click and moving it left and right. If you want to get rid of this thing on the left, which you won't have this originally, but you can collapse this by moving it right here. You can collapse this too, but it's not a good idea. You can collapse everything by either doing F12, and you can also bring up the debugger by clicking on here. Oh yeah, and also you can get rid of this by doing that. But that's just some of the really basic stuff. Now let's go into options, main. Let's go into platform, Windows. You can change up the product information. You can change up what its name is, and it's of course not, you put copyright and then your company name or name, and graphics, image, installer, display cursor, start full screen. You can allow the player to resize the window, and yeah. So, and I think we need to go into configure. Okay, not configurations, but it should be here in, no, not in Linux. It should be here in general. Yeah, you could set up the games per second. We are just going to set it up to 60 frames per second. But remember, there is something called a game loop. And in that game loop, the code or the game is updated a certain number of times. So if you set up your object in a step event to run this code, and the game frames is 30 game frames per second, it's going to run that code 30 times per second. And I'll go ahead and I'll show you, what I mean if you don't. And this was a hard concept for me to grasp. It might be really easy for you, but you may have to play around with it and stuff. But we'll go ahead and do apply. And if you want to start up your game, if you want to change, by the way, your platform, which I did buy a couple of platforms, but you may be using the trial version. If you want to click on this, you can run the game. And if we click on run, or if we click on F5, we can start up the game. Now, just to let you know, I'm recording my second monitor, so some of these games will open up on my right monitor. If I drag it out from the right, that's why, if you're wondering. And if you want to stop the game, you can either close it, or if it's stuck on a while loop, you click on this button, and it will stop the process. Now, let's finally get into making sprites. So you either right-click. We're just going to do SPR player, and we're going to click on import. Yeah, that's not that good, but this is a royalty-free asset that I wanted to use. If you want to import something called an image sequence, like if you have multiple images, you do import images, and you select multiple of them holding down Control. But I want to import a strip image because that's how these royalty-free assets work. We're going to click on character. There we go. And if we zoom in, there we go. And you do have to kind of eyeball it and estimate stuff. That's why I mainly like image sequences more. But people really do favor these sprite sheets. So we're just gonna make them go, walk to the right, and we can set up our offset down here. Oh, wait a minute. Oh, there we go. So you can actually set up vertical cell offset. So that's really cool. 16. We can set up the number of frames per row. We have 4 frames, so we can do that. But if we had 2 frames per row, we would do that. 4 frames per row, convert, import strip images. So And over here, you can actually set up the number of frames per second. Now, if you want to set it up by game frames per second, you can click here, but you can set up a sprite to run at a certain number of frames per second by running it like this. So left to right, and if we set this up to 2, it'll be 2 frames per second, which I don't like at all. 4 frames, that's okay. 8 frames, that seems kind of reasonable. 6 frames seems really moderate, so I'll go with that. And another thing is, this is a really important tool, and you're going to thank me for letting you know about this. If you click on Auto Trim All Frames, it'll remove all the space around it. Now, I do want to warn you, I mainly just suggest creating like one sprite mask and, you know, having it centered and stuff. For example, when you do create an object, you can set up one sprite to be its sprite mask or its collision box. Your sprite might look a little bit bumpy if you have multiple sprites in. So, because if you're changing sprites, it could, you know, change up the centering and stuff. But another, oh yeah, and that brings me to the other one, centering. So you want to click on middle center, and there you go. So you have centered the image. So what this means is that if you draw it at 0, 0, it's going to be drawn around this crosshair. Now, if I draw it to top left, it's going to be drawn at 0, 0, but it's going to be drawn over here. And a good example of this is if I went over here and I click on, okay, not background layer. If you click on new asset layer, this just allows you to add plain sprites. You can see over here that the sprite is actually centered at 0. So 0, 0 because its origin is at 0, 0. Now, if we set it up to go, and by the way, it's right there. If we set it up to middle center, it's in the middle. And it's at the same coordinates, but the reason why you want to do this is because if you wish to rotate your player or your sprite, you know, you're gonna have to center it, or else it'll look really weird. But let's go ahead and let's remove this. Next thing, objects. OBJ, player, and we'll throw in our object. Now, we'll go into a little bit on objects, but over here, you can add as many layers as you want. There are multiple layers: background layer, instance layer, tile layer, path layer, asset layer, create new folder. Now, create new folder, this just allows you to group together layers and stuff. How the layering system works is kind of self-explanatory. If you place something under that layer, it's going to be drawn under it. You know, just to, you know, let you know, the game will draw stuff in a particular order. So if you create an object and you created another object and they're in the same layer, the object that was created first will probably be drawn first. And if you ever use Paint.net or Photoshop or Microsoft Paint, I know that's a weird analogy, but or comparison, but you may notice you can drag certain images above other images. This allows you to control what goes above which. And a good example, and we'll use asset layers again. We'll throw in this sprite right here. Now, if we go into here, we drag this in again, and we can disable this. It's called, in the room, by the way, this is called grid snapping. You can click on this and configure it. This is so things look really neat. But if you click on this, it's going to allow you to move it wherever you want. But you can see here that this was created after, and it overlaps what was created second. So if something is drawn first and something is drawn second, it's probably going to be drawn above it. But this allows nearly complete, I would say this is complete control of, you know, how, you know, drawing works. So if I go into asset layer 2, and if I go into asset layer 1 and I drag in a sprite, I can just drag it behind him, and you can see here he's behind this sprite. So this is, you know, asset layer 1, this is asset layer 2. If I drag this under, and you can hold left click and drag it under, you can see here that he is now under this guy. And of course, the same thing goes with the background. So, and by the way, you can select multiple things, not just on GameMaker, but on Windows. If you hold down Shift and you click on something else, it will select anything in its path, but if you hold down Shift or you hold down Control, you can select multiple of them at the same time. Click on either delete or delete selected layers. Now let's finally go into instances. The same thing goes with instances, but you can see here, he's really small. If we wanted to stretch them out, by the way, we could click on this and scale images, and it says maintain aspect ratio. So I don't suggest playing around with this, so it might be a little bit of a pain. I do have a manual way of doing this. And let's finally actually get into you know, the built-in variables for an object. Now you can see here the sprite is moving. So you know, this is originally the sprite. It is currently animated. If we go into OBJ player, we go into create, there are some built-in variables that we can control. Now, if you have the name of another sprite and you do sprite underscore index and then you do name of sprite, of course it's just a placeholder, but if you put in another name of the sprite, you can change it. If you want the sprite to for some reason go half as fast, no, you don't do sprite speed. If you want them to go half as fast, you do image speed equals 0.5. Currently its image speed is 1. But I used to mess around with image speeds all the time in GameMaker Studio 1. They changed up the animation system for sprites, which is actually quite awesome. You can, by the way, preview a sprite animation by clicking on this above here. And you can see here, it's going to show us. Now, you can either in the room click on the instance. And by the way, if you're selecting another layer, you won't be able to... You should not be able to select it. So you can see here, it's not letting us select instances because we're in a different layer. If we want to rotate it, we can click on the side and we can do this. And we can rotate it however we want. If we click on one of the corners, or we hold left click on one of the corners, we can grow him. I actually kind of like this. It's kind of cool. But I'm just going to do Control Z, which will undo it, and we'll do image speed equal to 0.5, and we can do image underscore X scale, and by the way, these are called variables, but we can do image X scale equals 0, let's just say 4, so it'll be 4 times as big. You can see here, we enlarged it by 4. There you go, guys. A couple of other things. Whenever you do type in something, there are functions and variables. And you can use the built-in variable sprite height, which will give you the height of the sprite. And image X scale actually, image X scale and Y scale affect sprite height and sprite width. Sprite index, not only can you modify it, but you can actually tell which sprite it currently is right now. You know, there's all these other functions you can mess around with, but I'm not going to go into it. Sprite X offset. The offset is obviously, you know, the centering and stuff like this. So currently this has an offset, I guess, of 6 and 11. So, but now let's get into what variables are. Now, I've gone over this multiple times. Other people have, you know, stated this theory in different ways. There, I would say, is 3 aspects to programming. Variables and data, actions, well actually, let me say it in order. Actions, variables and data, and decisions. Now, when you perform an action, you have to state what the action is. Now, if I say walk 10 feet forward, if it is 10 a.m., I told you to walk forward, and the variable or the data in that statement, which would be 10, and the decision, which would be if. So if it's 10 a.m., then walk, which is an action, 10 feet forward. So you have the action, you have the data or variable that modifies the action, and you have the decision to decide when to do the action. And they all intertwine with each other because they can all control each other. If you can master all 3 of these, you can pretty much learn any programming language you want. Now, in the create event of an object, if you do create the object, or when the object is created in the room, it will run the create event code. If we right click and click on add event, and we click on step, any code that we write into that step event will be run all the time. It will be run, if there's 60 game frames in a second, that code will be run 60 times in a second. If there's 30 game frames in a second, it will be run 30 times in a second. And now let's finally get into an action. So let's first off perform an action. Now show underscore message. When you do state a function, which you can create your own functions later on with scripts, you can say show message, and then you can say in parentheses, which you have to put parentheses after a function, which, by the way, functions are actions. So you have to put in the data into this action. Now sometimes you will not have to put any data, and you will just have to put the plain parentheses after it. But in some programming languages, the reason why they want those parentheses is because you can pretty much save the reference to this function, or you can save this function inside another variable, and you can kind of rename it and do all sorts of cool stuff. But let's go into this. First off, the first data type that I want to go into, and we're not going to go into every single one, is going to be a string. Now, if you want a collection of numbers and letters and symbols, you want to put them in quotes. Now, we're throwing this into this action, and we can say, hello world. So if we go ahead and we run this, and remember this has to be enclosed in in quotes, hello world. So there we go. Now, just to let you know, it might malfunction if you put in another quote. You can also put single quotes in here, which is useful. You can see here, hello world. Now, another thing you can do, if a function takes two pieces of data, you have to separate that data type with a comma and then do next data. This is just a placeholder, but this doesn't take in multiple arguments. But if a function takes in multiple pieces of data, we call each piece of data argument. So this would be argument 1, argument 2, argument 3, 4, 5, and 6. This only takes one argument. Some take 0 arguments. So hello world. And you can add strings together. So if, for example, we can only say hello in one statement, we could do plus, and yes, you can use plus statements, or you can use plus signs. You could put in another string, so it would be hello, and it would have a space at the end, and we could do another plus if we wanted to, and we could do world. And there we go. And if we go ahead and we click on this, hello world, there we go. And we could throw in random numbers in here as well. So just to let you know, if you have a number without a quote, and you can't add numbers and strings together, you do have to convert them, but you could throw in plain numbers, and you can add, subtract, divide, and multiply them however you wish. But if you do not have quotes around them, they're going to be just regular numbers. And if we click on this, and the reason why is because it'll allow you to kind of modify it in a way. If you throw in a number inside of quotes, it will think that it's part of a statement. Now, if you add 5 in quotes plus 5 in quotes, it's going to equal 55. Now, if you add 5 plus 5 without quotes, it's going to equal 10. Now, you can see over here we did get 5, so you can throw in plain numbers, but this is the next data type that we're going into, real values. So these are called reals. They can be decimal, so we could do 5.4, 5, 0, 9, 2, 3, and we could do that. And there's a ton of other mathematical functions if you want to mess around with them. Sometimes it will estimate them, so you can see here 5.45. There's functions like round, and functions can actually return values as well, which is something I'll just go into. Round, and you see here we got 5. Actually, that's kind of weird. Oh, wait, never mind. Sorry, I thought that went up to 6, but show message. So if we do 5 plus 5, and you can add two numbers together, we can say show message 5 plus 5. 10. And that's being shown from this game over here. So just to let you know, one little mistake I made one time, and I've made this I still make this mistake to my this very day. If the code isn't running, make sure you actually place the object in the room, or else it's not going to run. But show message 5 plus 5. We can do 5 divided by 5, and we can see what happens. 1. If you do 5 asterisk 5, it'll multiply it. 25. And if you did 5 minus 5, it would be 0. Now another thing you can do is you can do modulus 5, and I'll just do 3 here. What this will do is it'll divide the number, but it'll actually give you the remainder. So if you can only divide, 3 only fits into 5 once, so it's going to give you the remainder of 2. You can play around with this if you want. It is really, really useful later on. But another thing here is we can actually throw in multiple parentheses together, and we can do 5 plus 5 times 5. Now just remember, PEMDAS still exists, so if we did 5 plus 5 times 5, it would be 15. So remember, PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. So you can see here it's 30. Well, actually, that's weird. Okay, I'm a little bit wrong there. Sorry. But 5 plus 5, 10 times 5. Now, what if I did want 5 times 5 to exist in the... Oh, wait, no. I'm not wrong. Because 5 times 5 is 30 plus 5 is... No, 25 plus 5 is 30. Sorry for doubting myself there for a second. But if I wanted this to be 50, I could throw in parentheses around this and do 5 plus 5 times 5. And yes, you can throw in any number you want, but you can see here 50. And in fact, we could throw this in another set of parentheses. And then we could do minus 2 after that. So you can nest as many parentheses in there as you want. Now let's finally go into variables. This is starting to look really, really messy. We can create something called a variable. There are 3 types of variables, just local variables, global variables, and instance variables. This is an instance variable, and we can reference this from other objects, since objects can interact with each other in a room. You could name a variable whatever you wish. Sometimes you might be able to get away with doing an underscore behind it. Actually, yeah, it looks like it does allow underscores, but if you can't use numbers first, but you could say first one, or you could if you want to declare a variable, which a variable holds data, you have to have the name of the variable, and then you could throw in some numbers after that name, like this. But you can't put in numbers first for some reason, but I mean, it could mess up some stuff. You know, it might be difficult for the game to interpret that code. But if we're going to come up with a name for this, we're just going to call this math, and we're going to make that equal to something. Now, just to let you know, if there's already a built-in variable or there is a function called math, you can't use it. Now, this is an instance variable. It's going to stick around with the instance. And just to let you know, when you do throw in an object in a room, you're technically creating an instance of it. I know I might word it just creating an object, but you're technically creating an instance because the objects here are actually just blueprints for instances. So when you create an instance, you know, you could throw in that instance right here. They're both completely different, and you can see here they each have their own unique ID. And this will allow you to reference certain objects specifically because they may have, you know, certain experiences. Some may be located in a certain part of the room, which you can access. And we'll go into a little bit later, but you could see here, math, if we do 5 plus 5 times 5 minus 2, and we throw in math right here. So currently math equals the value right here. We're going to throw in that variable in here, and that placeholder is going to make up for it. So you can see here, 48, we got it. Now, just to let you know, you could set up new variables. So if I did new equals math times 2, so you can make variables equal variables. You can multiply variables, and we'll go ahead and we'll do that right here. You can throw them in parentheses. You could do whatever you want with them. You could treat them exactly like numbers if there is a number in them. So if we throw in new, and just to let you know, 96. You could throw in semicolons. You're kind of supposed to. It's better programming practice. You kind of are supposed to throw in semicolons after each. Whenever you declare a variable and you create a function, what you want to do is you want to throw in a semicolon after it. You don't have to do this, but other programming languages require this. Like JavaScript, no, JavaScript I don't believe requires this, but Java definitely does. But you can see here it'll still work, but you know, it's supposed to indicate the end of a statement being made. But you know, that's pretty much it on variables or instance variables. We could say name. Currently, you know what my name is. My name is Ben. You could throw in text in here, and you could throw in name. Ben. And you could add them together. So if I did my plus name. And yeah, you could mess around with parentheses here if you want to. So my name is Ben. So another thing we can go into is the true or false value. There actually is no real booleans in GameMaker Studio 2 or 1. Depending on when this is recorded as of October 7th, 2017. Yo-Yo Games is always adding new stuff to GameMaker Studio 2, but the thing they never added was actual boolean values. And what a boolean is it's either true or false. Now, some things only have the answer of true and false. Some things in life have the answer of true and false. If you throw in true after this, true is actually a built-in variable too, but it's a placeholder for 1. Now, in Boolean logic, sometimes a number or sometimes a sensor, like a robot, may output a 1 in order to indicate true or a 0 to indicate false. The same thing goes with this. And we'll go into if statements right after this, but if we do value equals true, and we do show message value, it will equal 1. So 1. So the reason why I say there's no real Boolean values is because they're not really supposed to output 1 or 0. Well, some programming languages might output 1 or 0, but it's not a raw Boolean value. This is just a placeholder for the raw number that it represents. But, you know, just, you know, pretend that it is real because, you know, it's not really worth something to worry about. Now let's finally go into if statements, and these are my favorite. These are in the decisions aspect. We've gone over actions and we've gone over variables and data. If you make an if statement, now you have to state if first, but if you say if something happens, you can, in curly brackets, throw in the code, and that code will be run. Now this is the part where we state the condition. Now you don't have to nest these inside of a set of parentheses, but I strongly suggest you do. There are a couple of ways to check or to compare numbers. Now you can compare numbers, you can compare values, you can compare lists, or I mean you can compare arrays, dictionaries, numbers, and strings. You can check whether a number is greater than a number, less than a number, greater than or equal to, greater than, less than or equal to, or not equal to a number. And what do I mean by this? Well, first off, you have to state your condition. Now, we're going to say if 2 is equal to 2. Now, first off, we have to state 2. Now, there's two ways to do this. In most programming languages, you're supposed to put an equal, but GameMaker allows you to do either one. You could do 2 equal, and then the number that we want. So if 2 equals 2, then we have to throw in curly brackets after this, which will have to have an opening curly bracket after the condition. And after that opening curly bracket, we want a closing curly bracket, and we can throw in whatever code we want. We could even put this all in one line if you wanted to, by the way. But you could see here, if 2 is equal to 2, we're going to show message true. True. And you can see here, if we drag this over here, it's currently true. So if 2 is equal to 1, it's not going to run. So you can see here, nothing happened. Now, if we go ahead and we do, if 2 is, and you actually have to do it this way, if 2 is greater than 1, so you want to use a greater than sign, true, because 2 is greater than 1. If we want to do greater than or equal to, and we'll set this to a 2 as well, you have to put an equal sign after this, by the way, so don't get confused, is true. And if 2 is less than or equal to, and you may need this later on, so we could say true. If 2 is less than 2, which it's not going to run, it's a good thing I have a super fast computer to test this. And if we want to check if something does not equal it, you put an exclamation point and then an equal sign. And we'll throw in a 1 over here because we know 1 does not equal 2. And true. And just to let you know, we could actually insert variables into the conditions, and this is the part why I said that all 3 of these aspects are intertwined with each other, because you have to work with variables and data in the decision, you have to work with variables and data in the action, and you can change variables and data inside of the decision or inside of the action. And of course 2 equals 2 does not equal 1. Now if we do plus math, and we could do plus 1 either, so this is equivalent to plus 1, it's not going to run it, and you can see here it didn't run. Now if we do 1 times math, and there's so many ways to play around with this. 1 times math equals true because it still is equal to 1. If we do 1 times 4, which yes, you can do arithmetic in here, true, so that's still true because it's equal to 4. Now a couple of other things, if you throw in a plain variable in here, and if you're certain it's either going to be a true or false value, or it's going to be a 1 or 0, if you throw in the plain value in here, so for example, if value is actually equal to true, it's actually going to run it. Now of course value is equal to false, but if we throw in if value is equal to true, it should run true. So if value is equal to true. Now so whatever is in this condition or in these parentheses, if that is true, then it is going to run the code. And it just ran for me, it just gave me a true. Actually, let me just run that right now just to show you the proof. So there we go. Now here's the part where we want to check multiple things. Now yes, you can actually use variables as placeholders. We went over how you can use less than or equal to, greater than or equal to, or does not equal to. And we can also use and or statements. So if we want to check if we want to check for another condition at the same time, we can do that too. So if 2 is equal to 2 and 1 is equal to 1, and you can throw in and if you don't have this on your keyboard or you're just lazy. I was really lazy, so I just use the and keyword most of the time. But if you throw in 2 and signs after that condition, and by the way, you can throw these conditions in parentheses if you want. You can mess around with parentheses too. We can show message true. So true. Now if we make 1 is equal to 0, now another thing we can go into is the and statement, or the or statement. Wow, the or statement. Now what the or statement does is that it checks if one of the values is true. So 2 equals 2 is equal to 2, but 1 is equal to 0, so true. And you could technically play around with this, and you could do this as well. This is technically true, by the way. So currently, if we did something as complicated as this, and well, it's not really complicated, it's really easy. If 2 is equal to 2 or 1 is equal to 0, then that equals true. So this is currently true as a whole over here. and we can do and 8 is greater than 2, and we can do that. So you can use or statements with and statements with or statements, but you can see here true. Now, if we did an and statement over here, and we'll intertwine these, so you can chain this as many times as possible. You can make this condition area as much as you want, but you may need this eventually depending on what you're doing. I can't predict every single situation you're in because every situation is unique. But if we do 1 is equal to 1, true. And yes, you can also say if 0 is equal to 1, or 1 is equal to 0, or 9 is greater than 8. You could chain or statements if you want to. So true. Now, here's the next part we're going into. Now, some people usually go into this before going into this, but this is kind of important. Else statements. Let's just say that this is not true over here. So we're just going to throw this in. 0 is equal to 1. If you have an else statement, you can throw in an else statement or the else keyword after the curly brackets, and you can, or curly braces, and you can throw in another set of curly braces after this, and you can throw in another set of code. Now, just to let you know, you can throw in as much code as you want. Just to remind you, you can go insane. If you wanted to, you could even throw in another if statement if you want. So if 2 is equal to 2, I could throw in another if statement in here, but we could, if we use the else statement after this, and this is not true, it'll run this code instead. So if we go ahead and we do this, it's not true, so it's going to run false. So there we go, false. So there we go. And another thing we can do is we can do else if. Now what else if does is it's self-explanatory. It says else if this statement instead is true. So if I say else if 1 is equal to 1, it's going to equal false because 1 is equal to 1. Now if we do 1 is equal to 0, if we wanted to, we can either chain it with another else if statement, and you can do this as many times as you want, or we can throw in another else statement and we can say neither. There we go, neither. So yeah, that's pretty much it on this. If you want to, by the way, you could technically use or statements here as well. But that's that on if statements. I might have missed something, but this is just one of the functions that we can go into. Now, just to let you know, this is really important to mention. Sometimes when you run a function, there are some functions that allow you to create other instances in the room, and there's some functions that allow you to just simply do basic math for you. I'm not going to go into those. You can just look in the manual yourself by clicking F1 and searching it up. Functions can also return values as well. It may return a real, it may return a variable, it may return a real, it may return a string, it may return an array. It depends. But if we say math is equal to, and this should work, and we can either do SQR, which squares it, square root. These are just some examples. If we do square root of 4, this is going to output 2. And just to let you know, you can throw in variables in here as you want. And we can throw functions inside of functions too. So square root 4, that should be 2. You can see here it outputted 2. And I might as well go into here right now. In a script, if, for example, I named a script test, we can take in as many arguments as we want in here. I don't think I'm going to play around with these, but if you say, for example, return 20, And you can throw in whatever functions you want. And by the way, you can take in arguments by doing argument 0 through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It looks like it goes up to 15, but if we can do return 20 right here, and we'll do 20 plus argument 0. You can throw in if statements and other actions in here. But if we go into here, show message, test 20. So that's going to add 20 and 20 together, and that's going to return 20. And you can return that at the end. So just to let you know, if you do that return statement, it's probably going to cancel everything out. The script is just going to stop. If you have any code after this return statement, it's not going to run. But yeah, that's something that's also important to note. Everything runs in order. And now let's finally go into the step event. Now, here in the step event, we can check multiple things. Now, let's finally create this local value. The reason why you want to, local variable. The reason why you would want to create a local variable is because whenever you create an object and you create an instance variable, it's going to actually take up a small bit of memory. It might be a couple of kilobytes, might be a couple of bytes. Now, what if you want to create the most intense game? You've seen all those 3D games. If you are creating tens of thousands of objects and they have 1 byte of data, or they have a couple kilobytes of data, that's going to add up very quickly. Now, when you create a temporary variable, which in order to state it, you have to put a var before declaring the variable. You can bind data to it, but you can use those as placeholders temporarily, and it's going to be destroyed, or the data is going to be cleared right after the script runs. But it's used as a placeholder to make coding a little bit easier. So we're going to do variable math. Now, just to let you know, if you already have an instance value, or if you already have an instance variable created, you can't really do this. So don't do that if you already have a value. So we're just going to say placeholder equals 2, and we can do show message 2. Now remember that this is in the step event. So show message 2 is going to, oh wait a minute, no, show message placeholder is just going to keep running on and on and on. This is going to run 60 times a second. Now it's not really going to show a new message 60 times a second. So you can see here 242 Okay, I almost ran out of breath there, but this step event will just continuously run. Now, you can, of course, mess around with this by using if statements. And by the way, you can check the current time, the current second, month, minute, hour, and day, and you could technically compare it in an if statement as well. And just to let you know, an if statement, you could check whether something is equal to true or false if you wanted to. So that's something to keep in mind. But what we want to do is we want to detect keyboard inputs. So we're going to say if right, and we're going to check if somebody went to the right. We're going to use a function called keyboard underscore check, and then we're going to throw in the key, and we're going to do vk right. And what this will do is that whenever somebody holds down the right arrow key, and if you want to check if somebody pressed it down once, you do underscore press. You throw in the name of the key, and usually these are built-in variables as well. You would want to do vk underscore, and you can check these constants. These are not built-in variables. They're not variables because you can't change them. But you can see here vk enter. So there's vk left, right, up, and down, which are the arrows on your keyboard. And you can do vk right. And we're going to do something really simple here. And this is going to check this 60 times a second. And it's going to either output a true or false, or I would say a 1 or a 0. Now, if you went ahead and you looked into here, we'll actually say if right is equal to true, we're going to show message right if it's equal to true. Now, of course, we're not pressing it down, so nothing is going to happen. So, but if we hold down the right, 1, 1, 1, 1, 1. Now, I'm not holding it down. You can hear me press it. There we go, 1. So there we go. Right is equal to true. If we wanted to check for the left arrow key, we just create another variable, and we say vk left, and we say and left is equal to left, or well, that's a little bit, it's a little bit, left is equal to left. Yeah, left always is equal to left. So if I hold down right, it's not going to work, but if I hold down left too, it's going to work. So you can mess around with that if you want. Now, now I think we can finally go into a little bit on. Oh, actually, let's first off go into this. You may be having the question: what if I want to use the letters on my keyboard? They don't have constants for these. You want to do a function called ordinate or ord, and then you want to throw in the character in here in a string. Now you want to capitalize this, and I'm guessing because people have Chinese keyboards and Arabic keyboards, this is the reason. You want to do ord, and then in parentheses, and then you want to do quotes, and then you want to have the letter in here, or the letter or number, and you want that letter to be capitalized, and it will detect it. So if we do show message if right, and we'll just do this very quickly, show message right, we'll throw in a D here. So if somebody just holds down the plain D value, so there we go, it works. Ord D, keyboard check VK left, show message right. And we could do this for here as well, and we'll copy and paste this. Just to let you know, don't put a parenthesis after this. You don't need parentheses after these. Now let's finally go into the object. It was very important that I went into this. And just one more thing. You can check whether somebody pressed, released, or pressed down a button by doing mouse check button, MB underscore, and then these constants here. They're self-explanatory, but you're not really going to need them now. But let's finally get into the objects. So whenever you create an object, you're creating an instance in this room. Now the room is really important, the object is really important, and the sprite is really important, because sprites determine what you see, objects control both the environment and what you see, and rooms are the container for what you see and for the controllers. So I would say all the three aspects of programming and the three aspects in GameMaker are kind of universal. But that's how I word it and how I see it. But if you go ahead and you create an instance, it has its very own ID. Now, every single instance has its own X and Y value. Now, whenever you do move a object or an instance down, I'm going to call it an object, but it isn't actually an instance. If we move an object down, it's actually going to increase its Y value. And you can see down here, you can check up the Y value, and you can check my current coordinates on my mouse. Of course, every room has, a certain size. You can modify the size right here. So if we did 960 by 640, it would be 960 by 640 pixels. And this would be relative to the pixels on your monitor. Now, if we move this instance down, it's going to increase the Y value. Now, if we move the instance to the right, it's going to increase the X value. The reason why, by the way, the Y value increases, and I had to look up an explanation for this. I'm not just gonna, leave you hanging for that one little thing, or that one little detail. You might be wondering, why is this the case? It's because back then, TVs used to draw images from top left to right, then top left to right. So it would draw from here, top left to right. And then it would move to the right, and go down, go to the right. So it would, I don't know whether monitors actually draw stuff like this anymore, but that is why the Y value is inverted. So I know a lot of you have probably taken algebra, I hope. That is the exact reason why that happens, but you can see here, that's the case. Now let's go ahead and change the X and Y value of this object. So if you are controlling an object, you can change its X and Y value. You can change its size, you can change its rotation, and you can change its current location. Now, a couple of ways you can do this, and I forgot to go into this, just like I said, and I know, I'm sorry, I'm really forgetful. you know, but but if we have a value called math and it's equal to 0, we can actually add to it by doing math equals math plus 4. That's pretty obvious. But we can also do math plus equals 4, math minus equals 4, math divided by equals 4, and math times equals 4. And it would times, subtract, divide, or add to it. So if I did plus equals 4, it would add 4 to it. Now, the same thing with this built-in value. The object has an x and a y value, and we can keep adding to it. So if we do x plus equals 4, and if you do x equals x plus 4, that's also equal, but if we do x equals 4, it's going to put it into the x, it's going to put it into the x coordinate of 4. But if we do plus equals 4, it's going to move it 4 pixels to the right. If we do plus equals minus 4, or minus equals 4, it's going to make it go to the left. Now just remember, a step event can be run 30 or 60 times in a second. If the step event runs, since our step event is running 60 times in a second, you may not have set up your game frames, but I strongly suggest 60 frames per second, because 60 frames per second is awesome and it looks great. If there is 60 game frames in a second, it's going to run this 60 times in a second. So that means it's going to do x plus equals 4 60 times, or 30 times. So it's going to do 60 times 4. It's going to go 240 pixels to the right per second. And we're going to see it move 240 pixels to the right per second. And it's going to do this very slowly. And it's going to look smoother and smoother and smoother the more game frames that you have. But there we go. He's moving to the right. And you can see here, it's really confusing, but if we do, and we can do this here too, we can do image, we'll actually add to its image x scale as well, just for the sake of it. Image x scale plus equals 0.2, image y scale. Actually, this might be a bad idea. Just remember, that's going to make it grow exponentially if we do it, but it's going to make it grow. You can see here he's growing and he's growing and he's growing and he's moving to the right. Now, of course, the bigger the sprite is, the slower it goes. Well, it'll look slower. It's still going the same speed, but we can also modify it. We can also make it go down by doing y plus equals 4. So we can see here, y plus equals 4. If we do y minus equals 4, or y plus equals minus 4, it'll start going up. Now let's go ahead and let's finally create another object, just for the sake of it. And we'll do this just to show off. Image x scale is equal to 4. Since this is either going to be a 1 or a 0, we can make left equal to negative keyboard check A. And yes, you can have negative values in here. What we're going to do is we're going to do right plus left times 4, and we're going to say x plus equals right plus left times 4. Now, you don't want to completely use this as your movement code, because you will have to check for collisions eventually, but we could say, if we do D, you can see here it makes us move to the right. If we do A, it makes us move to the left. Another thing I do want to go into is, if right plus left does not equal 0, and this is the easiest code ever, by the way, for moving left and right, moving your sprite, you can actually mirror, or you can flip your sprite's image vertically or horizontally. If you do image x scale equals -1, it'll flip it. If you do image y scale equals -1, it'll flip it vertically. Now we're just going to do image x scale equals right plus left. Remember, if it equals 0, we're not going to see it at all. But if it is negative, it's going to flip it. Oh, uh-oh. Remember, this is going to be either -1. If somebody holds down both right and left at the same time, this is going to be 1 and -1, which will make this equal to 0. If somebody holds down right and does not hold down right and holds down left, it's going to be -1. The same thing, and vice versa. Now, we just probably want to multiply this by image x scale. It's either going to be positive or it's going to be negative. Uh-oh. Okay. All right. That's why, because it actually did invert it. So, times the, and we'll do this here. We'll make this multiplied. We'll multiply the absolute value of image x scale. What that'll do, what that did is that it inverted it. So, to the right. If you get the absolute value of a number, you just get the positive version of it. So, to the right, to the left. Just to let you know, if we wanted to, we could technically do 4.5 as well, since we can do decimals. You can see here, that's really cool. Now, what if we wanted to check for collisions with another object? And we can modify this. We're just going to do other player, and we'll play around with image blend right here. What image blend allows you to do is it allows you to modify its color. By default, I believe it's C white, but we're going to do C underscore, and we can throw in a color, so it will blend it into that color. Now, we're just going to make him, we'll make him navy blue, and we're going to say, and we're going to check whether we're colliding with him. Oh, yeah. Biggest mistake, by the way. Always remember to throw in your object in there. That's the biggest mistake I've ever made. So you can see here, we're currently over him right now, but what if we wanted to destroy that other player if we're, if we touch it? Well, we can check for collisions by using this special variable called instance underscore place or instance position. Well, instance position checks, it returns the ID back, but instance place allows you to check for that other object, but it will give you the specific ID for it. Now, I am going to place specifically these other players right here, just for the sake of it. And we'll just make him orange, just so he's easier to see. If we do instance place, X, Y, and we do the name of the object, if we collide with that object, this is either going to return a data type called noon, or it's going to return the name of the ID. And we can do ID dot variable in order to modify it. Now, what is noon? It's actually -4, but if we do instance place is equal to, does not equal noon, it's instance place is going to output a -4 if it's not colliding with anything. So remember, this is checking for specifically this instance. So if you have multiple OBJ players and one OBJ player runs into another OBJ other player, it's only going to affect, or the code's only going to be run from this OBJ player. And we'll go ahead and we'll save this right here. We want to save this here. Var key equals this. So it'll be, it's not something that we really need to keep, but key does not equal none, noon. Now, just to let you know, we can access math here. Since we declared it as an instance variable, we could do show message math, and we could do that. But we're going to do key does not equal noon, and we're going to say instance underscore destroy key. So we're going to destroy it. Now I'm going to show you the unproductive way, but if we go to the right, you can see here it destroyed it. And we have to collide with it specifically. Just to let you know, the collision mask is very specific. Currently, this is our current collision mask. If you want to set the collision mask of it to a certain other sprite, you go click on here. So you can modify it if you want there, but we can go here. So, instance destroy key. It's really simple. So instance destroy key. And, okay, instance destroy key. Now, what if we wanted to show some value that it has? Well, we're going to say math equals 5. And we're going to do show message key.math. And by the way, you could do this with its own built-in variables. So we could grab its current x value, we could grab its .image x scale. But if you have the name of the object or the specific ID of the object, you can actually collect data on that. So we're going to do show message five. because currently its math value is equal to 5. Now here is the unproductive way, or here is the inefficient way. There's another value, and I'm not going to go into every single one, but these are the most important ones. Place meeting x, y, and this will check for at the specific x and y value, but just remember, if you did x plus 20, be right back. Sorry, I had to very quickly answer a phone call. Alright, okay. I've been recording this for over an hour, so, you know, that's why. But if place meeting plus 20, y, obj, other player, and we do instance underscore destroy. And by the way, if you don't include an argument in here, you can throw in the name of either that ID, or you can throw in the name of that actual object. If you throw in the name of the other object, it's going to destroy all of that object. So if we do this, place meeting, and we do plus 20, x, y, malformed if statement. Oh yeah, that's one mistake I usually make, but you can see here it destroyed every single one of them because it checked that we collided with an object, but it destroyed all of that object. So I wanted to show you the solution first and not show you the mistake. But, you know, hopefully that, you know, you do understand that. So place meeting x, y, obj, other player. We'll go ahead and go ahead and delete that. And the last one, or the last collision function I want to go into is place free x, y, place free x, y. Now, if we make obj other player solid, what this will do is it'll check for collisions with anything that is solid. This is really useful because if you have multiple wall objects, you wouldn't want to do a position meeting for every single instance or every single name of that object, because you'd have to do it so many times. So place free is actually really useful. So you can see over here, it detected if we collided with it. But if we do solid, and we go ahead and we run this again, there we go. So we passed right through it. Now if we go into the create event, and we say obj underscore other player. So if you want to get a specific ID, you could do some other things. You could technically do global variables, which if you do global.value, this global.value, you could access global.value from another object, and you could access it from multiple rooms, but global.value can be accessed anywhere. If you do obj other player dot image x scale equals 5, and we're just going to modify its built-in variable just to be really simple. Dot image x scale equals 5. Now what I will tell you is that if this object doesn't exist, you may have to check if that object exists. So if you do instance exists obj underscore other player, this will check whether the object exists or not. And you could throw in an ID as well. And you can get your own ID, by the way, with a built-in variable called ID. So you could technically give that other object your ID too. But obj other player image x scale equals 5. I believe that this player is actually being created before everything else. So let's go ahead and let's drag this to the bottom. Remember, this is being created first, and this, and this. obj other player. We'll just set it up to 10. There we go. So we did this with the step event. I don't know why it didn't work with the create event, but that works with the step event. So you'll be able to affect every other one of those objects. And just to let you know, if we wanted to go into another room, and we can right click this and create another room, we'll throw this player right down here. But if we did, for example, if somebody pressed the space bar, and we did if space, then room go to, and you can either do room go to next, but it will go to the next room on the room tree, so you want to be kind of specific. We're currently in room 1, and the room that's actually at the top here first is going to be the first room loaded up. If we do space room go to 1, it's going to make us go to that room. Now everything, by the way, will be cleared in the last room, but if we click on space, there we go. So we're actually in another room right now. So if we do click on space, it'll make us go to that room again, and it will erase everything. Now there are some ways to do this. You can set room persistent or room set persistent. But you know, that's pretty much it on the basics. I've already gone past like an hour for this, and if you've been watching this for over an hour straight, I hope you did learn something. And thank you for bearing with me. But yeah, guys, that's pretty much it on the complete basics. This is how you get other objects to interact with each other. That's how you check for certain collisions. And we're going to be utilizing all of these skills. I haven't gone over every single thing that we're going to go into, so some things might be a surprise to you. But hopefully this is a good refresher for you. But anyways, guys, I'm Ben from Suspendy Studios, and thanks much for watching. Peace.